So this is a special video talking about the skill, sketch a curve. So before we move on talking about how to sketch a curve, what is the questions right here, okay? So for example, okay, we provide you 1 mHCl together with 1 gram of Mg. If I ask you to draw a curve or sketch a curve, okay, which is the reaction between 1 gram of Mg, but this time we have 2 mHCl. So I will expect you to sketch a new curve, okay, for this one, okay, comparing to this one. Okay, so basically, okay, how can we sketch a new curve? I will recommend you to have 3 steps. First of all, you're going to draw 2 tangents, okay? What is the tangent? Okay, remember, tangent is related to the rate. So you have to consider the new experiments. You are having a steeper rate, same rate, or less steep rate. I mean, the slope, okay? Second one, okay, will be related to the end time of the reaction. So end time of reaction, that means that, okay, whether the reaction end early, same time, or later, okay? So this is the end time point, okay? So if you're the same here, okay, same as 1M, okay, that will be the same end time. Earlier, that means you have the reaction complete earlier time, okay, and then maybe some of them they may later time. Or the third one, okay, it will be related to the amount of products, okay, form. Remember, okay, the product form is not necessarily the same amount. Sometimes it can be more, sometimes it can be less. This one is easier to explain, so I will start this one first. The amount of product will be depending on the amount of limited reagent. In this case, if we are talking about magnesium is a limited reagents, then okay, the magnesium, if it remains the same, the level of the products, okay, in this case the level of the product will remain the same. But if I change to say 3 gram, then maybe more product will be formed. Then the endpoint levels, okay, it will be above, okay, than this level. So draw 2 tangents. What means by that? Okay, I would like to show using these examples. So this one is the first type of reaction. If I have a modified reactions, okay, I change, say for example, the concentrations of the reactants. Okay, so if I say that the reaction is going to be faster than the original one, then I will expect the tangents I'm going to draw will be steeper than the previous one. The previous one, okay, will be something like this, right? So steeper, okay, so therefore I'm going to have it like this one. I will draw 2 tangents. So one will be like this. If I imagine the reaction continue going like this way, then I will have another tangent like this. Okay, so by doing so, okay, actually I try to shape, okay, the curve, okay, how we're going to draw. So this one is just a sketch for us to know, okay, roughly the curve have to be like this, okay, and then we're going to draw like this way. Okay, so roughly I can have an idea, okay, how the curve look like. I will recommend you to use 2 kind of maybe you use pen together with pencil. Okay, if you're having this tangents, use pencil because you can erase it later on. When you give the answer, you use the pen. Okay, so try not to use the same color of pen, okay, because they will look very messy, just like right here, okay? So this is the part. When we draw the tangents, okay, we have to consider the rate of reaction. And for the rate of reactions, actually depends on several things, okay? The rate of reaction depends on the concentration of the reactant. Higher concentration, normally the rate will be higher. Temperature. Higher temperature, the tangent, okay, is to be steeper. Surface area, if you have a powdered form instead of a lump form, okay, powdered form versus a lump form, okay, we'll know that, okay, powdered form have a larger surface area, so the rate will be faster, so the slope of the tangent will be steeper. Last one will be the presence of catalyst. If you have catalyst, then maybe the reaction rate will be higher. The slope of the tangent will also be steeper. Okay, so basically these 4 factors will affect the slope of the tangent. Then we're going to talk about to determine the end point, end time of the reaction. End time of reaction will be a little bit complicated because you have to consider the rate of reaction together how much product you're going to form. Okay, so I will just give you a few cases here. Say for example the most common one, case 1, we have different rates. but we all the time produce the same amount of product, then that one is easy. If you have the rate faster rate, same amount of homework to do, but you do faster, okay, you end earlier. So example here, say for example, mg is the limited one. Both of them, they have 1 gram. Same amount of limited reagent. So we know that we have same products. Okay, so we need to do the same amount of products, but okay, one of them is higher concentration. That means this one is faster rate. Okay, this one is a slower rate. So for faster rate have to produce the same amount of product. Of course, this one will end earlier. So you will see that faster rate end early, slower rate end later. Okay, so that is very simple for you to understand, and most of the questions, okay, will be like this one. But actually we can have other scenarios to have different rate and different amount of product. Say for example, in case 2, we can have faster rate, but at the same time we have more product to be formed. Okay, so in this case, if you have faster rate, you do faster, but you can't end faster because you need to produce more product. So at that times, okay, it can have many possibilities, but normally, okay, we roughly have the same end time. Okay, so let's have a look, okay, of the situation here. Our reaction A, we have 1 m HCl and 1 gram Mg, but this time the limited reagent it go to HCl. So you'll find that the 1 m HCl change to 2 m, the concentration double, the amount, okay, the number of mole of HCl will be doubled. Okay, of course we're saying that same volume, okay, for HCl, but this one, okay, will remaining same. Okay, so if this is A, if this one is A, I'm going to draw B. B, first of all, I have to consider this one, okay, 2m at a faster rate. Faster rate means steeper slope. So I'm going to draw 2 slope. Okay, one would be like this. Sorry, not good. One would be like this. Okay, second one would be like this. Okay, but I have to consider because we have more limited reagent. So I will end later, not later. I will have more product. More product, faster rate will consider the rate more or less the same. So A will end at somewhere here. So I will expect B will end at a higher level, but at the same time, more or less the same moments to end. So the whole things, when I draw, okay, will be more or less like this. Faster rate, steeper slope, but end at the same time, go horizontal like this. Okay, so basically from here, we can see that faster rate and more product form. Okay, you may argue this point, can it be here or can it be here? I don't know. Okay, it really depends on the ratios of the rates, how much is faster by percentage, how much more product is going to form. So this one actually we need a few more information for that, but roughly, okay, you can consider that, okay, more or less the same. Okay, case 3, can we have a faster rate but less product form? Of course you can. Okay, you can do faster your homework, but at the same time you have less homework. Okay, so let's have a look of reaction A. We got 5 gram lump form. Lump form means a large piece of marbles, and this is the limited one. Okay, limited reagent. Both of them, they're having same HCl, same concentration of HCl, but this time, okay, we have less limited reagent. Less limited reagent, that means that, okay, we have less product going to be formed. Okay, and this is a powdered one. Powdered one means larger surface area. Larger surface area, that means you have faster rate. So basically for B, we will anticipate a faster rate. So you can see there's a slope like this. Second one, okay, we will see that we have less product form. So the level of product, okay, will be somewhere here. Okay, I haven't considered the ratio of this one much, okay, but some of the questions you may need to consider. Okay, I just want to draw the things nice for you to see. So this one, okay, we have a less product form. Okay, so we will expect, okay, they will end earlier. Okay, original time will be here, so they end earlier, maybe like this one. Okay, so basically, okay, this is how we sketch the curve. Okay, so summary, okay, the skills in sketching the curve, okay, you may consider to draw two tangents to make a smooth changing curve. Okay, instead of like the last one that I've drawn, just change like this way. This is not good. Okay, this is much better. You draw two tangents can help you about that one. Determine the end point, okay, the end time, okay, whether it will be earlier than the original one or later than the original one, and also the amount of product it remembers. It have to be depends on the limited reagent. So I just got a matrix here. You can have a look. If we have the rate faster and you need to produce more product, more or less you consider the same endpoint time. Okay, if you have faster rate, you have to produce same amount of product. Of course, you can end the reactions earlier. If you have faster rate and you need to produce even less product, of course, you have to be earlier than the normal one, okay, than the original one. Okay, so in the other way around, if you got a slower rate, you need to produce more product. Of course, this will be a slower reactions. Okay, you will end later than the original one. Okay, but if you have same amount of product, you still have a slower rate. Sorry, you have to end late as well. But this time, if you have a slower rate, but I'm not that harsh on you, okay, I just need less product. So more or less, maybe you end at the same time of comparing to the original one. Okay, so you have many possibility here. Okay, it can be faster rate and at the same time, faster rate and earlier, slower rate and at a later time, same rate, have less product, so therefore you end earlier than the original one. Many possibilities. Okay, so when you mark, okay, you have to remember basically for the curve, you have to think of whether you have faster, same, or slower, and you have to have more product, same product, or less product. These will be something that you help. Also, you can consider the end of time, earlier, later, or the same. Okay, so just remember, okay, the slope of the tangent will be affected by the four factors affecting the rate of reactions. Okay, so they are listed here. So basically, this is the skills that I would like you to have, okay, for sketching a curve. That's all for this video. Bye bye.